Hey science students, and welcome back to another lesson with me, Leslie, from Tesla Tuition Videos. Today we are doing the chemistry topic of percentage yield. Let's get to work. Right, so percentage yield, what does it mean? Well, I find it helpful to first look at the word yield. So the word yield in chemistry means the quantity of a product that is produced in a chemical reaction. Now, when it comes to chemistry and chemical reactions, you will find that sometimes you don't make as much product as you thought you could, right? Now, you get two types of yields that we will eventually put together in our formula. You get an actual yield and a theoretical yield. Now, maybe as a chemist, you are planning to do a certain chemical reaction and make a certain product. So maybe you go ahead and do very meticulous, careful calculations to find out the maximum possible quantity of a certain product in the chemical reaction based on a certain quantity of reactants that go together. So based on your calculations, the maximum possible quantity of a product that you can produce, that is called your theoretical yield, because that's the maximum quantity of the products that you can produce in theory based on calculations. Then maybe you actually go to the chemistry laboratory and then you try and perform that same chemical reaction with the same quantities of substances you used in your calculations. And you might find that after completing the chemical reaction, you don't make quite as much of your product as you thought you could. The quantity of a product that you actually end up making in a chemical reaction, that is called your actual yield. Now, using your actual yield and your theoretical yield, you can now calculate something called your percentage yield. Now, the formula that we're about to look at for percentage yield, it is not given on your formula sheets usually. This is one that you have to remember and memorize off by heart for tests and exams. This is the formula. So percentage yield equals actual yield over theoretical yield multiplied by 100. Okay? Now, you will always be calculating percentage yield for a specific product in your chemical reaction. To get the percentage yield of a certain product, you take the quantity you actually got, your actual yield of that product, divided by the maximum possible quantity, the theoretical yield that you calculated for that product, and then you multiply that by 100. Okay, now you'll see I've written a couple notes for actual yield and theoretical yield again. So actual yield is the amount of product you actually produce in a chemical reaction. Now, sometimes it can be hard to pick up from a question that they've given you a quantity that's an actual yield, but often they'll use words like actual. So they might say 10 grams of sodium hydroxide are actually produced. Or they might mention the experiments happening in a lab where that quantity was produced. Or they might even say something like a chemist or lab technician finds that they produce so much of a certain product. All of that is a clue that they are talking about the actual yield of a certain product that was actually produced in the experiment. Okay. Now, theoretical yield, as we said, is the maximum possible quantity of a certain product that can be possibly made in a chemical reaction, and this is based on careful calculation. And oftentimes, those calculations may involve the limiting reagent. Now, if you've seen my lesson on limiting reagents, you'll know that it is the limiting reagent that determines the maximum possible quantity of products that can be formed. So by converting from the moles of limiting reagents, you can find the maximum quantity or theoretical yield of a certain product in a chemical reaction. Now, I've been talking about these yields as quantities, but what actual units are you using? Now, these quantities for actual yield and theoretical yield, they can be a number of things, such as a mass in grams or kilograms. That's sort of the most common form of calculation. But they can also be volumes, for example, volumes of gases, or even mole quantities. The only rule is that your actual yield and your theoretical yield, they must have the exact same unit. So if you are using a mass for your actual yield and theoretical yield, which is most common in the questions, then they must either both be in grams or they must both be in kilograms. Okay, let's take a look at our example. Okay, let's take a look at our percentage yield question. It reads as follows. Consider the balanced equation below. H3PO4, that's phosphoric acid, plus 3NaOH, that's sodium hydroxide, gives Na3PO4, that's sodium phosphates, plus 3H2O, which is just water. They go on to say that 10 grams of your phosphoric acid, H3PO4, and 10 grams of NaOH, sodium hydroxide, are combined. Now, 1.1 says, determine the limiting reagents. It's very, very common that when you have a percentage yield calculation that you are first asked to find the limiting reagent. So that will be 1.1. Now, 1.2 says, a lab technician actually produced 9.8 grams of Na3PO4, sodium phosphate. Now, they want us to calculate the percentage yield of Na3PO4. Okay, now as discussed in my lesson on limiting reagents, to find the limiting reagent, you must first calculate the number of moles that you have of each reactant. Now, they've given us the mass of our two reactants, and before I calculate moles, I'm just going to go ahead quickly and calculate the molecular or molar masses of each substance. Now, you are going to need your periodic tables in order to do this. So we've got 3 hydrogens, which each have an atomic mass of 1. We've got 1 phosphorus, which has an atomic mass of 31, and 4 oxygens that each have an atomic mass of 16. So the molecular mass of phosphoric acid, H3PO4, is 98 grams per mole. Now let's quickly work it out for my sodium hydroxide, NaOH. You will find that you get a molecular mass of NaOH as 40 grams per mole. So now that we've got that, let's come back and work out the moles of each of our reactants. So let's first work out the moles of H3PO4. It's going to be mass over molar mass. So it's going to be 10 grams over our molar mass of 98. And let's quickly work that out. 10 divided by 98 gives us a number of moles of 0,1020, and that's moles of your H3PO4, or phosphoric acid. Now we repeat the same process to get the moles of our sodium hydroxide. So moles of NaOH equals mass over molecular mass. That will also be 10 grams, now divided by 40 grams per mole as a molar mass. And 10 divided by 40 should give you 0,25 moles of your NaOH. Okay, right. So now the next step to finding the limiting reagent is to pick one of my two reactants to test to see if it could be limiting. Right? And we're going to choose either one, and I'm just going to choose sodium hydroxide, okay? But you should arrive at the same conclusion even if you chose phosphoric acid. Now, when you test to see if a certain reactant is limiting, you convert the moles you have of that reactant into moles of the other reactant, and then you'll compare that to how many moles you actually have of the other reactant to see if it's possible to use up the first reactant. So what I do here is I take my moles of NaOH and we're going to convert them into moles of your phosphoric acid, H3PO4, that would be needed to use up our sodium hydroxide. So I write the word needed underneath to make it clear. So taking my moles of sodium hydroxide, 0,25, divided by the coefficient of sodium hydroxide, which is 3, timesing by the coefficient of what I'm looking for. H3PO4's coefficient is 1. Remember, when you don't see a number, it means 1. Right, so now let's work out how many moles of phosphoric acid would be needed if we were to use up all of our sodium hydroxide? Right, and what you will find there is that you should have 0,0833 moles of H3PO4 that would be needed to use up my sodium hydroxide. Now we compare that to how many moles we actually have of phosphoric acid. And look, we have more than what we need. 0,0833 moles is smaller than 0,102 moles, so we have more than enough phosphoric acid to be able to use up our NaOH. So I like to even acknowledge that by saying, but have 0,1020 moles of H3PO4, which is more than enough. You have more than enough phosphoric acid to be able to use up your sodium hydroxide. So because sodium hydroxide can be used up, it is the limiting reagent. NaOH is limiting. By saying it's limiting, you're saying it's the limiting reagent that gets used up completely. Okay, so we've just completed 1.1 where we found out that the limiting reagent for this reaction is NaOH, sodium hydroxide. You'll see I've now written limiting in red above it. I also wrote down the moles of that NaOH, our limiting reagent, as 0,25 moles from the previous question. So now in 1.2, we are being asked to find the percentage yield of Na3PO4 or sodium phosphate. Now in 1.2, we were told that when a lab technician actually performed the reaction, they actually formed 9.8 grams of Na3PO4. Now that's actually our actual yield as a mass in grams. And the actual yield, you don't convert to moles. You actually keep it as a mass. Right, so we've got the actual yield of our product. And to work out the percentage yield, we also need its theoretical yield. So now we're going to find the theoretical yield of Na3PO4 by first converting from the moles of the limiting reagent. So let's do that now. So remember that the limiting reagent is used to determine the maximum quantity of a product that can be made. And so we must convert from our limiting reagent, in our case, NaOH. Right, so we're trying to find the moles of Na3PO4, sodium phosphate, and we're going to convert from the moles of our limiting NaOH. So we say 0,25, which was the moles of sodium hydroxide, over the coefficient of sodium hydroxide is 3, and you multiply by the coefficient of the substance you're looking for, and no number in front of Na3PO4 means a coefficient of 1. Right, so let's work that out now quickly. So 0.25 divided by 3 times by 1 equals 0,083 moles of Na3PO4 or sodium phosphate. Okay, now, because we were given the actual yield as a mass in grams, then to be able to work out percentage yield, we would also need the theoretical yield to be a mass in grams. So at this point, we're going to convert the moles of sodium phosphate into the mass of sodium phosphate that will be the theoretical yield in our percentage yield formula. Right, so you might remember from stoichiometry formulae that as a formula, moles is equal to mass over molecular mass. So if I rearrange the formula to make small m the subject of the formula, then you're going to see that now small m, or mass in grams, is the product of moles and molar mass. So moles, small n, times by molecular or molar mass, capital M. And you may have noticed on my board that I've actually preemptively worked out the molar mass of sodium phosphate as 164 grams per mole. And now we're going to use that when we find the mass of sodium phosphate. So as we said, mass of sodium phosphate is moles times molecular mass. And the moles we converted from our limiting reagent, sodium hydroxide. So we take the moles of Na3PO4, 0,083, multiply by our molar mass, 164. And now let's quickly get the mass of sodium phosphate. That's actually going to be our theoretical yield. What you should get here is a mass of 13,612 grams of Na3PO4. So this is the maximum possible mass of sodium phosphate that we can make, and it's going to be our theoretical yield that we'll use in our percentage yield calculation in a moment. Okay, so now we're almost at the end. We just need to calculate percentage yield. So you must write the formula for percentage yield. Percentage yield, as we have seen, is equal to actual yield over theoretical yield times by 100. Now, I've made sure that both my theoretical yield and my actual yield are masses in the same unit of grams. Now, remember our actual yield that we had written previously, I erased it now. It was 9,8 grams as given in the question, divided by our theoretical yield that we just calculated, 13,612. And then you're going to times that by 100. So I get an answer here on my calculator of 71.995, and we're going to round that to a percentage, 72.00 percentage yield of our Na3PO4. So there we go. In 1.2, we found the theoretical yield by converting from the moles of our limiting reagent and then converting that into a mass, which is what the theoretical yield was. The actual yield was given in the question, and with actual yield and theoretical yield, we were then able to work out the percentage yield of our sodium phosphate. That brings us to the end of today's lesson on percentage yield. Head over to our website for our full-length science videos.